Every time your brain forms a thought, blinks an eye, or fires a single impulse across its neural network, your body physically burns cellular energy. When that energy starts running low, most people reach for a cup of coffee to refuel. The common assumption is that the caffeine provides an incoming payload of raw metabolic energy to power those depleted cells. In reality, black coffee contains 0 calories. Its chemical structure provides no molecules of ATP, the actual biological currency your cells use for power. Caffeine is entirely devoid of fuel. Instead of providing power, it initiates a chemical process to temporarily hide the signals of exhaustion. This diagram compares glucose, a true energy source, with adenosine and caffeine. Notice that the actual fuel molecule is distinct from caffeine, while the structure of caffeine is almost identical to adenosine. Consuming caffeine does not insert new energy into your system. It forces your body to borrow alertness from the future at an unsustainable physiological interest rate. To see exactly how this chemical loan operates, we are going to model a specific scenario, keeping a human subject awake for 48 consecutive hours using only caffeine. Pushing the human system through 2 full circadian cycles without sleep is an extreme biological stress test. It allows us to observe the body's natural fatigue suppression systems as they attempt to cope and eventually fail. This 48-hour timeline tracks extracellular adenosine accumulation versus wakefulness. Time is measured on the x-axis and unbound adenosine on the y-axis. Monitoring this continuous data plot maps the chemical interaction between caffeine and the nervous system. By observing the biology pushed past its natural limits, we can isolate the exact moment when pharmacological suppression transitions into neurochemical debt. We start the timeline at hour 0. The subject is fully rested and their central nervous system is at a baseline state. Here is an empty neuronal adenosine receptor alongside our timeline. Every expended ATP creates a byproduct called adenosine. These molecules accumulate steadily in the extracellular space. When adenosine docks, the receptor transmits a somnogenic signal, creating the physical sensation of sleep pressure. At hour 16, the volume of docked adenosine hits a critical threshold. The brain receives a signal that the body requires immediate rest. Physiological exhaustion is not the absence of energy, but the active chemical presence of bound adenosine. At hour 16, instead of allowing the subject to rest, we introduce a massive dose of caffeine to completely override the natural sleep cycle. At the neuronal level, caffeine molecules flood the space. Because caffeine shares a structural homology, it triggers competitive antagonism. Caffeine reaches the receptors first, physically occupying the docking sites. It lacks the markers to activate the receptor, so it fails to trigger the sleep signal. By occupying these receptors without activating them, the blockade effectively blinds the brain to its own accumulated exhaustion. As the timeline crosses the 24-hour mark, the subject experiences subjective alertness, yet no new metabolic fuel has been introduced. Caffeine does not clear the actual biological need for sleep. It merely unplugs the brain's internal sensor for tiredness. Maintaining the receptor blockade for the second 24 hours requires continuous redosing of the antagonist. During this window, physical symptoms like an elevated heart rate and dilated pupils occur. These are frequently mistaken for a surge of real energy. This diagram outlines the HPA axis. Blocked sleep receptors register as an anomaly, prompting the pituitary to signal the adrenal glands for an emergency. The adrenal glands respond by releasing a low-level stream of adrenaline, locking the body in a mild state of fight or flight. This is an emergency stress response, not cellular energy production. The heart rate increases to brace for a threat, but the underlying cells remain depleted. While the adrenal system creates an illusion of vitality, a severe neurochemical situation is developing in the brain. Cellular metabolism has continued uninterrupted. The brain has been producing an endless stream of adenosine, pushing the accumulation curve upward into a critical state. Because the receptors are occupied, none of this adenosine can dock. It simply pools in the extracellular space, reaching extreme, unnatural concentrations. This localized flooding acts like water building up behind a physical dam. The blockade is holding for now, but the pressure behind it is mounting. Keeping the subject awake has not prevented fatigue, it has merely delayed chemical delivery, generating an immense neurochemical debt. At hour 48, we end the experiment and cease all administration of the antagonist. The liver finally clears the caffeine from the bloodstream. As the concentration drops, the caffeine molecules detach from the receptors and dissolve. This is the moment the pharmacological dam fails. With the blockade removed, the 48-hour backlog of unbound adenosine rushes in. Thousands of sleep-inducing molecules dock simultaneously, hitting every available receptor at once. This sudden influx of somnogenic signals creates the overwhelming sensation known as the caffeine crash. The crash is the brain being hit with 2 days of deferred fatigue signals in a matter of minutes. The crash represents the biological debt collector calling in its marker. The physiological ledger must balance. This chemical mechanism governs the daily reality of regular caffeine consumption. The brain has a drive to achieve homeostasis. When baseline systems are consistently altered, it initiates a survival response called neuroadaptation. In response to constant receptor blockade, the central nervous system physically upregulates, growing entirely new adenosine receptors on the neuronal membrane. Normal amounts of adenosine can now easily find an open site, transmitting fatigue signals even while caffeine is present. This increase in receptor density locks the biology into a strict tolerance loop. Long-term users require increasingly larger doses simply to reach a normal state of alertness. Caffeine is a master molecular mimic, but it is not a metabolic fuel source. You can temporarily trick your neurochemistry to defer fatigue, but the biological debt collector always gets paid with interest.
Thanks for watching Body Science School. Please like, share, and subscribe the channel for more.